Brown Dog Gadgets live.
Brown Dog Gadgets Live. As always, I'm Amanda, your education outreach coordinator here at Brown Dog Gadgets. And I've got Pete behind the camera.
Hey.
We do actually have an additional guest with us today. We've got, that's on my face, Josh. Josh, that's lots of boxes.
He's over there.
You.
Can we hear him?
Hi.
Hi, Josh.
Is it working?
It is working.
It's working.
I feel like you need a green screen in your office. Or to clean it up.
Boxes.
Boxes.
It's true. Awesome. We are going to talk about motors today. But before we do that, as always, if you have not followed us on our social media platforms, please check it out. We've got Facebook, Instagram, Twitter or X, and YouTube. And if you are looking for any of the motors that we show off today or anything in general, you can find most of our stuff at browndoggadgets.com. And if you have any questions, feel free to email us at help@browndoggadgets.com and Josh will answer those.
You got it.
I won't. Josh will.
Nah, he can do it. He can do it.
Awesome. All right, today we are going to talk about all the different kinds of motors we have here at Brown Dog Gadgets. I'm going to talk about some of them. You do realize that you are unmuted, so the throwing of the box
You want me to mute him?
is kind of noisy. Welcome, Josh. Welcome. So I'll start off with some of the more simple motors and then, I'll rely on Josh and Pete to give you the details of the more complex motors. All right, let's switch to that overhead camera.
Don't worry.
All right.
I'll bring him back.
Yeah, there we go.
Yay.
Oh,
We'll go right
whoa.
there. That's a good spot for Josh.
But then if you come in, Pete, how does that work?
I take his place.
You just block him out. I like it. Perfect. Awesome. The first motor we wanted to talk about today is used in quite a few of our projects here at Brown Dog Gadgets. This is our peel and stick vibrating motor. My favorite part about this bad boy is the peel and stick aspect. You just peel off that back layer and stick it down and it stays. For this, we use it a lot in different projects that we want to vibrate, obviously, since it's a vibrating motor. One of which is our bugs and our critters. So this is the motor that's used to help these little guys vibrate around out in the sun. It's right underneath that solar panel, and that's why it's so nice that it's peel and stick, because then it just sticks down to the bottom side of the solar panel. You can't type on the keys, Josh.
I can mute him.
That might not be a bad idea.
Okay, he's muted.
He's muted.
What's that, Josh?
So this is the vibrating peel and stick motor that is in all of our solar bugs and critters. Quick side note, eventually your solar bugs may actually already have legs. This is just a quick little sneak peek at what's to come. Yeah.
Nice.
Nice Andy coloring job there.
Yeah. The crowd is beautiful.
And then this same motor is also used in our origami circuits kit. So if you get an origami circuits kit, we have that in there to use in projects like the robot vacuum,
Go kitty.
which is one of my faves.
Yeah.
What'd you say, Pete?
Go kitty.
Yeah. Or Jumpy Frog.
Yeah.
This guy's awesome.
Powerful motor.
It is. So that is the vibrating peel and stick motor. Josh, anything you want to say about this bad boy? I will let you talk for a moment if you would like.
Yeah. Yes. Okay. So the thing I'd like to say about that motor is that it's cool because it has fairly long wires on it, and also the amount of exposed wire on the end
You didn't say
is
cool beans.
pretty darn
So cool.
large. So it's much easier. You don't have to strip the ends of wires, which I know stripping the ends of a small wire like that is basically just you destroying wires because they're nearly impossible to strip by hand. So yay, we did that. So either if you're soldering them or most likely using conductive tape with them, they're
Maker
really
tape.
easy to connect to. Our maker tape.
Maker
Hashtag
tape.
maker tape.
Hey.
That's cool. Cool beans all around.
Maker tape. Awesome. Yeah, so you can literally just put it right over the end of it and get it set up that way. So this is our vibrating peel and stick motor. Next up, we've got our barrel motor. So this one is a cylinder, and then it has a little shaft, a little
Offset weight.
offset weight at the
Yeah.
top.
Just like your old pager
Wow.
from the
Wow, Josh.
1990s.
Did you just zoom yourself in? I like it.
And I centered myself.
I love it. So this one is really interesting. We use it in our BristleBot. And you know what I didn't grab? Pete, will you grab
What?
the spinning box on the bottom shelf over there?
Yeah, I'll get a spinning box for you.
Thanks. So this motor is on our BristleBots. It should be on the bottom shelf. Spinning. Oh, up top. Sorry, under crowns. I have them labeled to help me. But I forgot to grab my favorite part of the spinning projects. Just give me the whole thing. Thanks. All right. So for this little guy, don't have him connected right now because otherwise he would just vibrate off the table and the battery would die and then he would be no use to me. But once we connect that with a little bit of maker tape, he moves around like a crazy guy.
Oh.
Yeah.
I have to try to keep him in view. So that is the barrel motor on a BristleBot. But recently we have found that there is a fun way to use this for spinning projects. So not just the vibrating, but spinning as well. So we have created...
Don't tell me it's a circuit that spins.
What? No way. Some spinning projects. So we've got our spinning snowflake. And the cool thing is it's literally just stuck onto the top of it with some double-sided foam tape or hot glue. And it uses that motor in a little bit of a different way. Here, we'll even get the bin out. We got the ghost. We got some Halloween spinning projects. And then my favorite is my one-eyed monster. And his eye spins. So lots of fun ways that you can incorporate using that barrel motor into spinning projects, not just the BristleBot. What you got, Josh? Barrel motor.
Also, long wires that are extra exposed
true.
on the end to use with whatever. Because again, nothing is worse than trying to strip the ends of really small wires. You know, Amanda, back in the day, I had to
Tell
buy
me.
little pager motors and solder wires onto the ends of those because I had no money as a teacher, and they were weirdly
Teachers
expensive.
are so rich.
I know.
Not at all.
And so
And
now
then-
it's like, hey, we just learn from that because again, it's yeah, never try dealing with little tiny wires. It's a fool's errand.
Josh, you know what I'm
As
going to
they
get you for
say.
Christmas is a really nice set of wire strippers, and then you'll be able to strip those.
Ooh, there we go. Or you just get
That's why I
them
need some
already
teeth.
stripped.
Exactly.
Yes, that is
Hey.
good. That is handy.
Trying to make it easier on the educator in the classroom.
Yeah, I think for all of our motors, you don't need to strip any wires, right, Josh? We've got the wires ready to go. Tape them down.
Absolutely.
I think the pump
Pump might be the one.
is the one.
Pump is interesting. Also, if you are watching right now, please feel free to comment, to ask a question. Just make fun of Josh. That's fine too. Something in the comments. We'd love to interact. We'd love to hear from you. You can make fun of me also. Josh looked really offended, so it's fine. You'll be okay. You have chips in there with you. And I do not mean potato chips. I mean Chips the dog.
He's a good dog.
Thought I'd specify for people.
Good idea.
So we've got our vibrating peel and stick motor, our bristlebot motor. Next up, we have our regular sized, I'm gonna call this the regular sized DC motor. And I was gonna take the fan top off, but I really pushed it down on there hard. So Josh, tell us a little bit about the DC motor, because this is where we start to I don't have as much information.
Okay, well, it is a small DC motor.
Thank you.
With a fan you can put on the end of it. So this is a really handy small motor for making things spin or turn. It has a high RPM but low torque, meaning it will spin a lot but won't push much. So don't try using it for like a race car or something. We like to use this guy because it's really, 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 really easy to power from any power source, whether it's a small battery, a hand crank, or more importantly, a solar panel, because it only takes about one and a half-ish volts to get going at a reasonable speed. So it's really nice to work with small solar panels outside, because when you take a solar panel outside and try to turn an LED on with it, you realize, oh, you can't actually see your LED because it's bright outside. So you really need something that spins or moves if you're going to do something solar outside. And that's why we have such long wires on it. There are very long wires, I believe almost a foot of wire on there. That seems like a good number. Let's say 8 inches.
8 inches, I think, is a good estimate.
8 inches, there we go. 8 inches, again with extra exposed wire on the end, so we can just use some maker tape to tape it to the back of the solar panel. We got these specifically for a solar house, used the solar panel, but it has a number of good uses. In addition to, turning on its own, you can also force it to turn by, say, blowing on it really, 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 really hard.
Hey,
and
Josh.
you get a moment. Oh my gosh, Amanda's got something there. Amanda, show us how strong those lungs are.
Well, we have a new product that's coming out eventually. I say eventually. It is our wind wand. Hey. And if you blow on it hard enough, exactly, I can get that LED to light up. Let's see if I can actually make it happen. We'll see. Did it go?
Yeah.
I was also trying to make sure I didn't put my head into the camera.
Do it again. Flip it over.
All right.
Flip it upside down. Oh yeah, definitely.
There we go.
You got it.
I needed a better angle.
So it's a really good example of wind energy. It's not going to power anything useful because it takes so much energy to get it to turn. But it's a great demo that every motor is a generator and every generator is a motor, just not really efficient always in that area. This is just an LED, a little bit of conductive tape, and the motor with a fan. It's kind of like what we have on our solar house. But it's a handy little demo. Oh, it says demo on the backside.
Hey, you were supposed to see that.
That's my demo
cool.
unit.
Now
It's the demo.
people know it's a demo.
It's true. We're still working on
it
this.
beautiful? But
It's looking
those
great,
are
though.
really
It can
handy
stand
little
up.
motors in general to have
Fancy.
For a variety of projects. But the thing is, keep in mind, like it is a high RPM. Let me bring up my stat sheet. Okay, so this motor is officially rated, and by the way, the give or take, 1.5 to 9 volts of power, anywhere from 1,700 to 7,000 RPM. So it spins quite quickly, but it has like no oomph behind it, no torque. So it is just great for making very light things spin very quickly. In this case, a little fan like that. Now, Amanda, you could put hook a little battery up to that and just have a nice little fan to cool you off in the summertime, because I know
Beautiful.
you go on long walks in the Wisconsin sun, just like
Always.
so cool, so
That's
cool.
right. I did measure the length of the wires, and it is
It's
between 7.5 and 8.
Officially, the official mount on our manufacturing spec is 8 inches. Give or
Like
take.
20 centimeters.
20 centimeter. You're right, Pete. It is 20 centimeter.
Thank
You
you.
are so metrically correct. That is what it officially is.
That's the best kind of correct.
Wow.
All right. Anyway, metric.
Yeah.
Awesome. So that is our regular DC motor.
Yay.
Yeah.
Awesome. Next up, we have this fun guy. Tell us all about this guy, please.
So on our website, this is labeled as a DC gearbox motor / generator with crank, because it can be two things at once. As I said, every motor is a generator. Now this is a very common gearbox motor. You'll find these guys all over the internet. They're very, very common electronics projects. Very simple nylon gear system on the inside. And this will take between 3 and 6 volts of power, then output anywhere from 120 to 250 RPM. So rather slow in comparison to the like 1700 minimum on the other fan. But that's that little gearbox on the inside. Now the nice part about it, you get 8-inch wires on the end. This is something you'd want to use for like making a small like car or whatnot move. It would move very fast, but it has a lot of torque behind it, a lot of oomph. So it'll move something like that. That's why people use these in like little robotics projects and simple movement projects galore. But we've also found it's really, 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 really handy as a hand crank. Like,
Oh, yeah.
yeah. And it'll actually output between 1 and 6 volts DC.
It works a lot better than
know.
my breath did.
Yeah.
Yeah, and so you can power up like we've when Pete is actually has the office award for like most volts out of a hand crank. As we tested him
true.
out, he got over 6 volts.
I
The
got
rest of
like
us just
7.
aren't as awesome as Pete.
It's true.
He does not skip arm day. But you can power things like other fans or other motors or LEDs from it, or hook it up to a little voltmeter to see how much it'll go. But it's a really cheap and simple way of doing a hand crank generator. So much so that when you purchase one off our website, it comes with a little fun attachment to make it into a hand crank, or you can take it off. Pete designed that in our office, so it's a Pete design. Go Pete, go!
Okay.
Pete's
I'm
on
gonna
it.
go.
He designs a lot of
It's-
our stuff, let's be real.
Well, our 3D printed stuff, that's for sure. But anyway, so yeah, it's a really kind of handy way, and much cheaper than buying like an official like hand crank. They're weirdly expensive at like 3 times the cost.
And
Or-
they're not
what-
very cool looking.
Well, it's a nice way of hooking up like a few LEDs with some conductive tape, another motor with a fan, just some small things. You're not going to be powering anything too crazy with it, but it's a nice, obvious connection point for students, and also is inexpensive and really tough to break. That's why one of the reasons we tried really hard in our office to break a couple of them by cranking them like really, really like a lot. Like how much will it take to destroy? These are the tests we do in our. By the way, this is the tests we do with our products. Like we bring new parts in or try things out. What does it take to break the thing? Because we know students can be rough on things. Students. There's always that one kid. There's always that one kid who's trying, especially
one,
when you get to
though?
middle school.
We all know that
One?
one.
They're
kid.
strong.
Well, there's one that's worse than all the others.
That's fair.
It's true.
None of them are
but-
gentle with things.
No, and this will take a lot of abuse from students, and also it has a benefit of as well. You want to say take these out and use them and make a car or something with them or other projects. You can just take that hand crank aspect off. So it has like a multi-use functionality to it. And again, it's that motor is a generator, generator is a motor. It has a lot of weird uses, and we're like, hey, this is for us more useful as a hand crank than it is as a motor for what our purposes are. So anyway, it's a nice fun thing to do with those little guys, and they'll take a lot of abuse from students.
Well, it's just so many educational possibilities with this. That's what we're working on right now, is figuring out, what do we want to include lesson-wise and activity-wise in selling this as maybe a product or a kit.
And well, in a kit, yeah, it's up on our website actually. All these things Amanda's
Yeah.
showing are on our website.
That is
now.
true.
They've been in a warehouse for like a year. I actually put them up on their website. It's been a while. They collect a lot of dust, but yeah. Hey Pete, make a note. We should probably have a design, since we know what attaches the end. Like make a couple of things that can attach to like some wheels, or I don't know, a giant fan or something to the end. Like if people, we like putting out 3D printable files. If we design something in house for a project or whatnot or an activity, throw it up on the website. And I'm sure there's other people that put other things out there, like our tape holder. But we should design our own, like a nice little wheel or something to go with it.
Amanda,
ooh,
can you turn the crank in one direction slowly, then the other, just so
Yes.
people see it does rotate the blade in different directions.
Maybe.
So there's some really cool lessons we can do about polarity and about how you can turn the motor, and then the motor can power an LED depending on the direction it's going. So there's some really kind of deeper stuff than just making a thing go that we
Trying
can
to
get
make
into.
it go slow is really...
Yeah.
Well, for instance, if you hook up two LEDs on, say, a simple parallel circuit on a piece of paper, but the LEDs are backwards from each other, so one's positive negative, other one's negative positive, you can actually see, like, when you turn one way, one LED turns on, turn the other way, the other one turns on, because you're changing the polarity of the circuit involved. And again, that's a really easy demo. That's so easy to show, like, oh, look, this is what we do with the motor, polarity. Those very simple connections, and the kids can do all the work themselves, which is also a big bonus by the time you get to, like, that 5th, 6th grade on up. And the lessons are just, like, they're so easy to write, so we're going to try to write a bunch of them. It's just, like, these are easy concepts to do and fun to do. So anyway, that's on our website, too. It's a handy little tool. I highly recommend those little gearbox motors, whoever you get them from. But ours come with its own little crank, because
That's
why
right.
not?
And then before we move on to the other motors, I would love for you to throw anything in the comments about, have you used any of these motors before? Are you liking a specific project so far? Do you have a question about any of them? Please throw some kind of interaction in the chat. Thank you. All right, next up we've got our large DC motor.
Now, a large DC motor is a DC motor that's larger. There we go. Now, it also comes with a larger fan. And I think it comes with 2 fans. If I remember I need to double check my original inventory quote. I think it should come with both the blue fan and the red fan. I need to double check. But this is a 6 to 12 volt DC motor, obviously much larger than the other motor. Amanda, would you
It's
take
heavy,
the other
too.
motor and put it side by side for comparison? It's a much
Absolutely.
beefier, much more substantial. I mean, one's a snack, the other one is a meal, so to
That's true.
speak. But that's also because it also has RPM of 6,000 to 12,000. Basically, however many volts you put into it, between 6 and 12, that's many RPM you get. And it has a lot of oomph behind it, a lot more torque as well. Wire length of also 8 inches, 20 centimeters, give or take, in there. But it puts out a very high RPM with a good oomph, and we use that in our bubble blower project because it has a lot of a nice solid burst of air to blow bubbles from. So if you've ever seen us at a teaching conference, you'll see the bubble blower there. People ask about it all the time. This is the exact same one we use in our demo at the teaching conferences, and it's a handy, strong gust of wind off of that fan.
Well, and this would be a good place for us to check out the video of the bubble blower.
Okay, I'm going to play it.
Okay,
There might not be sound.
that's okay.
Okay, pretty cool.
Awesome.
Oh, I wonder if we
and
could
there's
use
definitely-
this motor to power the Windwands motor, thusly creating a wireless power transmission.
Probably, maybe not. Anyway,
Try
it's a handy motor. Like it's a beefier motor. It's a bigger motor than you typically will find, which is why I wanted to get it, because finding a good motor combination for projects was always a thing I ran into issues with in my own classroom, because there's so many motors. The right motor for the right job, the right amount of torque, RPM, and whatnot can be a hard thing to figure out if you're trying to make a random project with students. And it's not like motors are free. They have a bit of cost to them, so buying a bunch of motors is not always an option for educators. But this is a good little guide. Now, in that video, Amanda, you saw we were using a microbit
I did.
to control the project. And this is a question we frequently get. How do I use a DC motor, a dumb DC motor, which these are just dumb, there's no controlling involved on them, with a microcontroller like a microbit or an Arduino? The key to that is a relay, which is essentially a computer-controlled switch. So what the microbit just says, hey, turn this on and off, turn thing on and off. Because if you try to directly plug your motor into a microbit or Arduino, motors draw so much amperage, so much, that they'll burn out a chunk of you'll basically kill whatever pin or what digital controller port you're on of your microcontroller. So hook it up to pin 16, try to run that big motor, pin 16 will be dead forever. And so what you would do in this situation, you use something like a 9-volt battery. There's a 9-volt battery plug, go figure. This is what we do in our bubble blowing project. You hook that and the motor up to the screw terminal on the right there, yay. And then you plug the microbit via a ribbon cable or Arduino via ribbon cable to the other side. And then you can sit back and hear that internal there's a little switch on the inside. You can hear it go click, clack, click, clack, click, clack, click, clack on the inside when it turns on and off, like clicking on, clicking off. It literally is a physical switch that's happening. Now the cool thing is this is a DC relay, so it works with DC direct current things like this motor. Pete made a gigantic art display once with a ton of basically light bulbs and AC relay switches hooked up to a Arduino. Pete, how many light bulbs were plugged into that thing?
It's 27, so it was a cube, a 3x3, cube type thing. So 27
And
relays.
so 27
going
relays.
constantly.
Yeah,
click away.
The room was full of clicks when I saw that. That was
I could bring
was a
that
few
thing
years
in.
back.
It actually had, I think, did it have 29 or 30? I can't remember. What's 16? 32, I think it had relays,
There we
but I
go.
only used 27.
Wow.
But a relay is a really handy thing to have around, and this is we have it on our website for like $350. It's a cheap component. Get them off Amazon or pretty much anywhere, and it's really handy for attaching weird DC things, especially motors. Really, I think it's mostly motors I see people using them with, but just to turn things on and off like this fan. So it's just really handy to have around for different projects or other dumb DC things. I'm actually struggling with like what other dumb DC things, Pete, might you plug into a relay?
Ooh,
Oh, mechanical
Yes.
buzzer. There we go.
sure.
Because that's like not a piezo, but a mechanical buzzer. Those are fun. Or an incandescent bulb. So I mean, many classrooms in the past you'd use like that little incandescent bulb and a 6-volt battery and a knife switch. I did that in high school. If you're still using little incandescent bulbs and knife switches and whatnot, you could then have it be in its own little separate circuit from your microcontroller and a DC relay to turn it on and off. Yay, incandescent
Josh,
bulbs.
you could also use the self-sticking motor or the barrel motor that we use. So they're
Yes.
tiny, but you also just can't plug those into the microbit. They do need to
No.
have some voltage. So
And same thing with the geared motor too. Again, you want to have the geared motor being turned on and off by a microbit or Arduino. You would use this as well. Again, just it's not tough to hook up. It's really, really, really simple. And if you're doing anything microcontroller related, please do that. Pete has written a very nice guide on how to use a relay with a microbit, with code and example projects and whatnot on our website for anyone to use. So please use it if you need it.
And it really-
Brown.gadgets.com.
yeah, and it really is as simple as if you've written code to make an LED turn on and off, you can control that relay. It's actually the same code. You're just turning a pin on and off, basically. So that's about it.
So there's good examples Pete has written for that. So yeah, that's the big DC motor with a fan, called large DC motor with a fan on our website.
Exactly.
Good name.
Awesome. Next up, and I believe you said we use the relay with this too.
Yes,
Yeah.
this is our DC water pump because we have a lot of people who want to do a smart plant watering system or a plant care system with a microbit. And to do that, typically you want to have a little water pump involved. So we tried a bunch of water pumps, and there's a little tiny, very white water pump for like $4 on Amazon. It is horrible. The wires are very short. They're super thin. I know because a customer needed something very fast. It's the only thing we get in. We actually soldered wires onto the wires that were there because they were so thin and horrible. It was anyway. So we sourced a better one, and this is a nicer motor. It does not get submerged in the water. It sits outside the water, and it comes with 4 feet
Does this go on
of
here?
tubing.
It does.
It does. So
Oh,
you'd
there
say
we go.
you'd cut to length. We give you a nice long length. You'd cut it, say, maybe in half. Plug one into one port, one into the other. And then, you stick one into a cup of water, one into your plant, and, you give it power and it just pumps water. Now, it does pump 100 milliliters per minute at 12 volts. Oh, yes, but it works between 6 and 12. We actually power it with a 9-volt battery because 9-volt batteries are very easy to use. And they're 9 volts. And
Wait, do you use
we're not
this
running
too?
it all the time.
Yep.
Yes, indeed. Because you
Here's
need
a
a relay need. There we go. And
Why is it so large?
because you did a great job, Pete. Actually, that's for our old Bitboard, which had a relay
Yeah.
built into it. This was a few years back, but no one cared about that, so we stopped putting it in. It's okay, Pete.
We're working on
we
updates
have-
for all that.
We're updating it with a new pump and whatnot, but it's a really handy little thing to do. Now, Pete's actually working on updating your plant watering system in general, adding in a light component as well. But again, you just add power to it, whether it's a battery pack or with a regular on and off switch, or hook it up to a microcontroller via a relay. And we use it with a moisture sensor that we also now have on the website, titled Moisture Sensor. There's a guide on our website how to use that with a microbit. So, put into soil of a plant, you can say, hey, when the dryness or moistness drops to a certain level, run water pump for 30 seconds or 10 seconds or a minute, and then wait and then test again. Very simple, very easy way to talk about hydroponic growing, indoor growing, smart plant and agriculture systems, which are a big upcoming thing in the farming industry, agriculture industry. Lots of fun articles about that. It's been kind of taken off, and doing it in a small home setting, a small demo like this is really easy to do, and talking about several variables. Now, for instance, you could as well, I chatted with somebody about this recently, have multiple pumps going to multiple sources of water, fertilizer, or other materials going into your plant, and control hey, once a day, give it 50 milliliters of fertilizer. Moisture sensors activating the one with water, so on and so forth. So you can actually make it more complicated with a microbit very easily. But there's lots of fun ways to take it to a larger, more extreme way for in the classroom. But it's a really nice little pump. Of all the pumps we've tried out way too many small DC pumps. It's rock solid and will last you many years. The really cheap one will last you maybe a year or two. And that's the whole thing. Would you spend less money, but you have to replace it more often? Or get something that you buy once and never have to replace because, yay, it's never going to be destroyed. Now, the current batch we have do not have wires off the end. I think eventually, in like a year when we have to reorder more, we'll get wires attached, but that's nice big points to just honestly wrap a wire around or alligator clip to.
Or
Yeah,
maker tape
I mean-
on somewhere.
Maker tape it on. I mean, I would even just use a piece of solid core wire and bend one of the ends around it. Doesn't take much. And we're talking like 6 to 12 volts of power at a low amperage, so it's very safe. Just don't lick the battery.
I mean, that's
I know.
My favorite
in
thing
general
to do.
some good advice.
But it's a nice pump. Like it is a solid one, and you can find these on Amazon too. Like similar versions of this. They're actually more than what we're charging $10 on our website. I think they're like 12 to 15 on Amazon. But yeah, don't get the cheap little white ones. Those are horrible. The wires alone are just a nightmare to work with. Let alone anything you submerge in water. Just a motor being submerged in water. I don't trust that.
No.
Right.
And it comes with tubing. 48 inches of tubing, which should be plenty.
Absolutely. Awesome. Do we have a
Yay.
video of the
We sure
Plant
do.
water.
Do.
awesome?
Plant water.
Let's
Here we
check
go.
that out.
There we go.
Very cool.
I enjoyed the slow motion water there.
Yeah.
Also, how big that plant has gotten in our break room because it's much larger.
2 years
It's like
ago.
twice the size of that now.
Yeah.
So.
Well, and I
Really
love the
neat
fact that we created it using the Lego bricks as well. I think it
Yeah.
makes it so engaging.
Lego makes all your physical things easier.
It's true.
Easy together, easy apart.
Next up,
Speaking of Lego, there we go. These may look the same, Amanda, but they are in fact very different. These
Josh,
are
they're
both
two different
True.
color. Did you know that?
they are different color, and I put this
I
guy
know
on here to
once-
remember. Did you know?
They're physically the same body, but they contain many internal wonders. So the gray one is a 270-degree servo, and the orange one is a 360-degree servo. Let's start with the gray one first. What is a servo? Well, that's a great question, me to myself. A servo is a motor where it's hooked up to a potentiometer, so that your microcontroller knows approximately where it is. So Amanda can say, hey, when X, Y, or Z happens, when the temperature of the room hits 50 degrees, whatever, servo, go to this position, go to 45 degrees, go to 50 degrees, and it gets pretty darn close. It's fairly accurate. In this case, our servo goes between 0 and 270 degrees. And so that's the range it has of motion, and it gets within like a degree of where it should be. Like most small servos, it's pretty darn close. Any small servo you use is, going to be that way. Ours is brick compatible, meaning it will work with all of your favorite brick-based systems like Mega Bloks, or Duplo, or Lego Technic. It plugs into a microcontroller like a microbit or Arduino. Now, unlike a DC motor, these are designed to be used with a microcontroller, so they can be powered directly from that microcontroller and controlled directly from it very easily. They're designed to work that way. That's why we use this in our Bitboard Rover and other robotics projects. Now, going back to that bubble blower,
Not
the
this one,
wand
though.
we have moves up and down to dunk the wand into the bubble fluid. Then it moves up to position to get blown by the big DC motor. And this is the one where Pete has written code where you hit a button and it goes to position 1, which is in the bubble fluid. Then position 2 is in front of that fan. There's other motions in there too. Pete has it very fancily code written because he's a fancy man.
Sounds right.
He is. But servos are really, really handy for all sorts of robotics projects. I like to use them for all the projects I clearly make in my spare time. As a analog output to information my microcontroller is seeing. So for instance, using a distance sensor and having the servo point to the distance on a chart, like a little protractor semicircle printout, which we have. Andy, our curriculum writer, has made some templates up for that. Or having a analog temperature readout of the digital temperature that the microbit is seeing. What else? Sound meter. Basically, any of the sensors your microbit has already internally, you can output with a servo against like a little printed chart, and it's kind of interesting to see it that way. So there's lots of fun things you can do with it in addition to like simple robotics projects. In our Bitboard Rover, we use this as well as a bunch of Lego Technic-like material to make a nice gripper to grab objects. Yay, I'm doing the grabber motion.
Good job.
There. Look at that. I try. We include a little tiny a Lego-esque Technic piece there to fit on top as a horn. Any Lego axle piece will fit there, like say a Lego gear, for instance, another good thing to stick on there. But there's a lot of Lego pieces that connect to it, or Lego compatible components. It's just a little horn. It's pretty easy to fit onto a Lego-esque environment, either just straight down or using all the other attachment parts. You can see those in many of our guides. It's just really handy and easy to mount places. So there we go. We actually have a gear piece attached to it, and that gear connects to the other two gears, which then control the two pincers on the boop, boop, beep, boop on there. There we go. Look at that. Not a lot on camera much anymore.
You're doing great, Josh.
Thanks, Amanda, with all my boxes in my office.
That's right.
I'll clean that up eventually. But so these little servos are really handy. They have a decent amount of torque to them. We use it with our Bitboard, and they work off anywhere from 3 volts to 5 volts of input. On our Bitboard, we run them off 5 volt for a little extra oomph to them, but they run okay off the 3.3 to 3.5 volts as well. Now, the orange one may look the same. However, it's a continuous rotation servo, which is a servo that has the potentiometer ripped out of it. So it just either goes clockwise or counterclockwise, as well as some minor speed adjustments as well, like go fast, go less fast. It's really handy for simple robotics projects because it requires no extra hardware. It'll just run off a microcontroller. If you want to use a DC motor or a gear DC motor or a stepper motor, which can be very nice and accurate, you need additional hardware to control that. Whereas this guy can just go forward, go backwards, which is great for easy locomotion in robotics projects. With our rover, we can control the speed up and down, clockwise, counterclockwise, go, stop, making easy turns, easy forward, backwards, all that fun jazz. Is it going to do something, Amanda?
I mean, I couldn't show off the rover and not have a remote. I couldn't
I didn't know
not
if it was all
make it
hooked up.
move.
You could do that.
Of course it is.
Wait a while.
Of course it is, Josh.
Amanda's controlling that off a little remote control setup. She could use a single microbit as well, or a cell phone with a microbit app to make that happen. This is a kit we have, or if you have a ton of Lego Technic-esque pieces around, you could build your own with our electronics stuff. We even have 3D printable files for making your own Lego Technic compatible-esque battery holder that comes with our kits. But anyway, the orange is a 360 servo. Both those run off just fine off like our bitboard or with microbits and other things. There's code galore examples on our website for those guys. They are handy to use for all sorts of projects. Minimum, like, servos are one of those really nice things you want to have with your sensors for robotics and programming environments, because kids want to do something, want to have a project that interacts with the world in some way. A servo is a great way to take any inputs your microcontroller is getting and turn into an interesting output. Or again, like a simple dunk a bubble wand into some bubble fluid to blow bubbles. Not particularly difficult. Pete's the best project Pete ever has made at our office. Pete, I'm going to tell you this. Best one ever. Uses 2 of those gray servos and a really, really super cheap children's xylophone we got for $6 off Amazon, and a bunch of buttons, and it will you press a button and it moves to the right spot and hammers that horrible sound on the children's xylophone. And Pete also, in some of the demos he has, you can get programmed to play a song, really horribly sounding because it's a $6 xylophone. But again, 2 servos hooked up to a microbit. Not too difficult, a few Lego pieces involved, and it worked surprisingly well for what it was. It just sounded horrible, which was in a very engaging project because it moved. You're making a robotics project that did something that you can easily see and understand and envision what a bigger, better version would be, just with like nicer parts, a nicer xylophone. Pete, when a xylophone becomes nice, what do you call that?
Glockenspiel.
Glockenspiel.
He was
There
ready
we
to
go.
answer
You got
that.
the sound effect actually labeled Glockenspiel on his little control pad there.
Well, it's Glocken. Spiel's kind of long.
I know. But we have lots of projects on our website that use both of those servos. We have them on our website for sale. They come with a little horn on them. They're in a ton of our Crazy Circuits kits. We put them in tons of stuff because it's just very useful. But these are all the motors we have on our website.
They just keep going.
Yeah.
They do keep going.
And the little ones. The little guys.
ones.
Look at
And
that.
all the ones that, we try to tweak even the ones that we get, like fairly standard ones. We try to tweak them a little bit to make them a little easier to use. And I'm annoyed with myself for not getting wires attached to the pump ahead of time, but it's got big tabs on the back. In the future, we'll do that eventually. But yeah, any questions, let us know. They're up on our website. We try to make sure they're price-wise is comparable to what you'd find off like Amazon or other places, because motors are really handy for projects with the kiddos.
Awesome. So yeah, that is the assortment of motors that we have here at Brown Dog Gadgets. Hope you learned something. I know I did. Sometimes it goes over my head, but they're still here to tell me again. It's great.
Amanda keeps selling herself short. She has learned so much in the past.
I have
9 months.
I've learned
It's
a
been
lot. Yeah.
8 months.
I don't know.
So, are you making me just get ever so large on the screen, Pete?
I like it.
torch.
We're gonna see all his boxes soon. Ah, there's Pete. What's going on the edge there,
Wow.
Pete? Did your green screen turn up?
Oh, the camera's, hold on.
Oh, wrong way. There we go.
You're
There you
good.
go.
And as always, if you have not followed us on our social media platforms, please do so. You can find us on Facebook, Instagram, Twitter, X, and YouTube. If you are not aware, we have been doing a lot of YouTube live and YouTube short videos. So there's lots of content out there. Please go check it out. Like, subscribe, comment, do all the things. Smash that like, all the good stuff. You're getting a tour of Josh's messy office, I guess. If you have any questions, feel free to email us at help@browndoggadgets.com. Next week, we will be moving to 3 lives in a week, so Tuesday, Wednesday, and Thursday. We will be checking out some winter crafts, some holiday crafts, and looking at some basics of analog circuitry. Josh will not be floating randomly around the screen for those, so I hope you enjoyed. I think that's all we've got for you today.
That's
Hopefully
it.
see you next time.
All right.
Bye.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media @browndoggadgets. We'll see you next time.